Okay, so we are now live. Let's talk about systems of inequalities. All right. So what if I said I wanted you to graph y is greater than or equal to x squared? Any ideas on how to graph that? Berkeley.
First, you just graph x squared.
Y equals x squared, and that would look like
Parabola.
a parabola.
And then you just see, so I might get this wrong, but you just find all the y's that are greater.
So
find all that.
So we have to shade either the inside or the outside.
I think it's up.
The inside here?
Yeah.
Who agrees with them? 1, 2, 3, 4, 5. Who disagrees with them? Okay, you must be right. That's correct. Okay. Now, do I need to worry about a dashed line here? No, because
It's equal.
I got the equals there. Very good. Okay. So if I didn't have that, it would be a dashed line. How about, what if I said graph x squared plus y squared is less than 25? What do you think?
A circle.
Circle the radius of 5.
Circle with a radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Circle. Do I need to worry about dashing it?
Yes.
Yes. Okay. So it's a dash circle. It's nice when you have a wide erase board, you can just go like that. Okay. And what part do I shade?
The inside.
The inside, that's right. So we'll shade the inside. Okay? Not bad. How about x plus 2y is greater than or equal to 5? Seems like we're missing people today. Starting your Thanksgiving break 2 weeks early. Okay. What do you think?
Solve for y.
Yeah, let's solve for y.
Subtract x.
Subtract x.
And then divide by
2y greater than or equal to negative x plus 5, divide by 2. So y is greater than or equal to?
negative. Can you just write that? Or do you want,
We could split it up probably, that might be easier.
so negative 1/2 x
Negative 1/2 x
plus 5 halves.
plus 5 halves. How would I graph that?
Up 5 halves.
Go up to 2.5, right? 1, 2, 2.5, that right there.
And then you draw the line.
And then do I go up or down?
Down 1.
Down 1 and over 2. About right there. And is it a dashed or a solid line?
Solid.
Solid line. All right, so this might be easier to think of it. Is it the top side or the bottom side?
Where you're shading?
Yeah,
You shade the top.
top side, right? We want where y is greater than the line. Okay? This is a nice easy section. You wish this was in the last test. Except for now you're like, oh, the next test will be easier. So maybe it's good. Okay? All right, well, what if we say, what's x squared plus y squared less than 25, and x plus 2y greater than or equal to 5? And I tell you, I want you to graph it. Probably should use a darker marker, huh? All right, how would you do this one? Cameron, must be your turn.
Yeah, so you graph the top one's a circle,
Up on the circle.
the radius of 5.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay.
And then
Is it a dashed or solid circle?
it's dashed.
Dashed circle. Okay.
And then, so the other one would be x is greater than or equal to,
This is the same thing we just had here.
oh yeah. So then you
So
put a
it's gonna be
line.
like that.
Yeah.
So we're gonna go up to 2.5. We're gonna go down 1 over 2. And this one's gonna be a solid line, right?
Right. So then you shape up the line, but inside the circle.
Yeah, because we want it inside the circle, but we want, another way to rewrite this is y greater than or equal to -1/2 x plus 5/2. So we want this section shaded. Okay? It's a good section. A lot better than logarithms. Okay? All right, what if I said graph
You're off the camera.
and find, okay, thank you, vertices. Okay. So, graph and find the vertices, and I've got a bunch of lines. X plus 3y less than or equal to 12. Maybe I'll use different colors for this. I think I will. X plus y less than or equal to 8. X greater than or equal to 0. Y greater than or equal to 0. Well, it's a good thing I've got 5 colors today. Her graph is going to be, okay? So, Hunter, you look like you wanted to do this one. Which one of those equations looks easiest to graph? The top one? Oh, I see what I would have said the bottom one, but
Bottom one, yeah.
bottom one? What's the bottom one look like?
First straight line.
Straight line is a vertical or horizontal line?
Vertical.
Vertical line on the x-axis, right?
Yep.
And so it's a solid line, correct?
Uh-huh.
The second easiest one,
Second to bottom.
second to bottom one, and that one is
Vertical.
vertical line here. Okay. Third easiest one to graph,
Second one.
the second one. Okay. What does that look like? If x is 0, what is y?
8.
8.
Actually, I said that backwards. If x is 0, y is 8. So 2, 3, 4, 5, 6, 7, 8. If y is 0, x is 8. 1, 2, 3, 4, 5, 6, 7, 8. That solid?
Yes.
Okay, and then finally,
So it'd be 12, comma 3, or comma 4.
Well, okay, yeah, I guess we could do it that way. We could either solve for y, or we said x is 0, y is 4. 2, 3, 4. If y is 0, x is 12. So 8, 9, 10, 11, 12. So we're going to go this way. Okay. So x greater than 0, we're going to want to shade this area here, right? Y greater than 0, also this area. X plus y less than 8, also this area, and less than 12, so we're going to shade this area here. Okay. So it says graph, which we've done the graph, and find the vertices. Okay. Well, some of them are really easy to find. 3 of the 4 are really easy to find. So we have Stephen do that. By the way, I think I have 2 tests in here, so you need to come up and pick it up because I don't want to carry them around anymore. Okay? What's this vertex?
Don't ask me.
You can look at the board and tell me what that is. But you can tell me that point right there.
Just 0, right?
Just 0?
Just the x-axis, just the middle.
I want this point. I need 2
0,
coordinates for 0, 0. That's what I want. So that's one vertex. What's this one?
0, 7.
It's actually 8. 0, 8. What's this one? Actually, that's wrong. That's 0, 8. What's this one?
8, 0.
8, 0. Now, the hard one is to figure out what that one is. How do we find that point?
Just go rise over line. Just count it. Oh, wait.
I mean, we can kind of eyeball it. The question is it 2, 7 or 2, 6? Kind of hard to tell the way I wrote it, right? If only you had graph paper, it'd be easier to tell. How do we know?
We have 2 equations, 2 variables, so we can substitute or eliminate to find the points.
Basically, we've got the blue line and the green line. We need to find out where those are equal, correct? How do we do that? You said substitute or eliminate? Okay, so what do you want to do? Eliminate. We can eliminate the x's, so we're going to subtract the second equation, right? So x minus x is 0. 3y minus y,
2y.
2y equals 12 minus 8,
4.
4 divided by 2.
Is it gonna equal? Is that what you do when it's
Well, they're equal at where they cross, right?
Oh, that's true.
They're equal where they cross, okay? So y equals
Y equals 2.
2. So this was a good point there, so that's 2. Yes?
So can you only do like substitution if they have the same signs? Or like the same, like greater than, or less than, equal
Well,
to?
in this case, yeah. So we need the less thans in order to know what to shade, but in this case, we're solving for where are they equal to each other.
Oh, okay.
Okay? Because we want to know where they're equal to each other, right? Okay, so if y equals 2, Stephen has already lost interest.
Y equals 2.
How do I find x?
You do, you do the same thing with x, or you plug the y in?
Plug the y in.
You plug the y in?
Or which equation do you want to plug into?
The,
Blue equation or the green equation?
blue, green.
Which one?
What?
Blue, green?
Green.
You sure?
Yeah, sure.
Okay, good. All right, we're plugging into the green equation. We're going to get x plus
Plus 2.
equals 8. So x equals 6, which is right where I drew that, right? Okay, so what point is that?
6.
6 comma, two. Okay? Oh, actually, we don't care about that one, do we? We also care about this one. This one's where?
0, 4.
0, 4. Okay, those are the 4 points we need. 0, 8. Not
So we don't need anything that isn't covered in the shading area.
correct. Okay, you gonna ace my test, Stephen?
Yes.
All right, got an answer. Okay, this isn't too bad, right? All right. Should we do another one just like that, only harder? You're supposed to say, bring it on.
Yeah.
Oh, Julia, we should have picked on you, dang it. You gotta warn me next time. All right, so here we go. $10x plus 20y greater than or equal to 60. $30x plus 20y greater than or equal to 10. 100. $10x plus 40y greater than or equal to 80. And x greater than or equal to 0, y greater than or equal to 0. Those are super easy, right? Whose turn is it? You know, what's your turn? We want to graph first.
The X and Y.
X and the y, which are just right there, right? Okay? Now what?
Subtract the top and the bottom.
Why?
To get rid of the X's.
Well, we're graphing it. We don't want to get rid of anything while we're graphing it. Well, so we'll find the vertices later. When we find the vertices, you want to do that. But I just want to graph it right now.
Minus 2x on the top one.
Okay, I want to graph it.
Let's graph it right away.
Yeah.
Okay.
So you're doing the top one?
Yeah.
So if x is 0, what is y? No,
I say, wait.
that would be 3, right?
Sorry, yeah.
So 1, 2, 3. If y is 0, what's x?
6.
6. 1, 2, 3, 4, 5, 6. So I've got a line that looks like that, correct? Now, can you draft the green one?
Yeah. So y would be
If x is 0, y is?
5.
Y is 5. So I got 3. I really drew that badly, didn't I? Let's try that again. Okay, 3, 4, 5. If y is 0, x is? That was mean. That's a nice decimal, is it?
3.
0.3.
3.
No, it's 10 divided by 3, right? 30x equals 100 divided by 30. X equals 10 thirds, which is 3 1/3, correct? So 3 1/3 is about right there. So this one's going to go like that. Okay? And then the purple one.
X will be
If X is 0, Y is
double
2. If Y is 0, X is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so X is greater than 0. So let's make sure all my signs are right on this. Yeah, they're all greater than. Okay. So at this point, we want 10x. I'm trying to decide if I want to shade this or some other section. What do you guys think?
Shade what or which section?
Which section am I shading? We've got a lot of cross lines there.
Isn't it just the very top
yeah, in the middle.
if everything's greater?
Well, it might be easier to rewrite this, okay? If I rewrite these, I'm gonna erase this. It's 20y equals 60 minus 10x divided by 20. Gives me y equals 3 minus 1/2 x. Okay, actually, we want it to be greater than, right? So on this first blue one, we want y to be greater than that. So we want this area up here and all this area. Okay, on the green one, we're going to want 20y is greater than or equal to 100 minus 30x divided by 20. Y is greater than or equal to 5 minus 3/2 x. Okay, so once again, we want this area here, right? With the purple one, we want 40y equals 80 minus 10x divided by 40y, sorry, it's greater than, equal divided by 42 minus 1/4 x. So we want this area up here. And finally, x greater than 0, y greater than 0. So what area do we want? What area is entirely shaded by all three regions?
That top
This
big area.
tiny area right here. It's got purple, it's got blue, it's got, and it's black.
What?
Wouldn't it be above all of them? Because even,
Yeah, because then that would be false
if
for blue.
it's in that area, then it's below the blue one.
Yeah,
Oh, wait.
yeah, so it'd be above everything.
Yeah, it would just be above everything in the top right.
Oh, you're right. It's this area here. I wrote that wrong. This area here. We stop there. Yeah, you're right. We stop here. So it's this area here to here to here to there. On. Maybe I'll do that in red because it's hard to tell. Let's try that again. So this area here in red. Okay? So now we need to find the vertices. You should pick on Steven again because he's already lost interest, but I'm going to pick on Kalen because I'm a nice guy.
Okay, so to find the vertices,
Okay? This one should be the easy one to find here, right?
yeah, that one.
That's 1, 2, 3, 4, 5, right?
Yeah.
So this one here is
So it's 0, 5.
0, 5.
Yeah, and then those dots on the x axis.
Let's see, this one here should be easy to find.
Yeah, that one, I can't tell what that is. I can't tell what it's.
1, 2, 3, 4, 5, 6, 7, 8.
Okay, so then it's,
8, 0.
0.
So now we need to find this one here and this one here. This is where the colors come in really nice, right?
Is there a way to know just by looking at the equations how many vertices there's gonna be?
No.
No. So it's just
I
best
think you're
to
gonna
graph
have to
it
just graph
accurately.
it. Yeah, as accurate as you can.
Because my graph didn't look like there was that many.
So
Yeah.
we do the purple and the blue.
So the purple,
Sorry, we can do the green and blue, I guess.
it's the green and the blue.
Green
Okay,
and
so we
blue.
need to see where those two are equal.
Okay.
Okay? So we could subtract, right?
Yeah,
Because the y's will go away. So 10 minus 30,
-20,
negative 20x.
and then.
Y's go away. 60 minus
Oh,
100.
60 minus 100 is -40.
At this point, we want them to be equal to negative 40 divided by negative 20. Negative 20x equals 2. So x equals 2, which it looks like I drew it right here. That's 2, comma, and then what?
Is it, do we want to plug it back in, or can we see it on the graph?
Well,
Why?
it looks like it's in between 2 and 3 to me.
Okay,
So we probably should plug it in to be accurate.
so then you plug it back in, so the easiest one would probably be the top one.
Top one,
so-
10 times 2 plus 20y equals 60.
So then that's
Subtract
20
20.
plus 20y, yeah, sorry.
20y equals,
30, right? Or are you subtracting that?
oh, I'm subtracting, not dividing.
Okay.
That
So
would be
then
good.
that's
We don't divide.
40,
That would be 40.
and then divide by 2, 20, sorry.
Y equals 2. So this point is 2, 2, just like where I drew it right there, okay? And then we've got to get this point here. So this is the last point. What is that in the intersection of?
Isn't that the blue and the purple?
It looks like it is the blue and the purple.
Okay.
So we could subtract the blue minus the purple, right?
Yeah, get rid of
So
the
10
X.
minus, so I'll put a 10 here, right? So 10 minus 10, 20 minus 40 is
-20.
negative 20y, and 60 minus 80,
-20.
negative 20,
So y equals 0, or not 0, equals 1.
divided by negative 20, y equals 1. Okay, so y is 1, which we can see right there. So this point here, the y coordinate is 1. The x coordinate is
Just
4.
what is that?
plug it into which one?
Plug it
Either
into
the top one or
blue.
the third one.
So we'll plug it into the blue.
The blue one.
Yeah.
So 10x plus 20 times 1 equals 60. Subtract 20. 10x equals
40.
40.
So
X
x
equals
equals
4. So that is 4. Okay, so I didn't quite draw that right, but that's 4. Okay? So you might want to use graph paper on this one. Okay? All right then. All right. Let's see here, x plus 2y greater than or equal to 8. Negative x minus 2 plus 2y less than or equal to 4. And 3x minus 2y less than or equal to 8. So same thing. Let's turn these lights off, and it must be your turn. What do you think?
Sorry. So the first graph, intercept when x is 0, y would be 4.
Okay, when x is 0, y would be 4. 1, 2, 3, 4.
And the x-intercept would be 8.
1, 2, 3, 4, 5, 6, 7, 8. Into solid line.
And then
Okay.
the blue one, the y-intercept would be 2.
Say that again.
The y-intercept is 2 on the blue one.
So if I set the x equals 0, y equals 2. Okay.
And the x-intercept
And y is 0,
negative 4.
x is negative 4. 1, 2, 3, 4. Okay.
The last one, when x is 0, y is negative 4.
Y is negative 4. 1, 2, 3, 4.
And then when y is 0, x is maybe 3/8.
8/3.
8/3.
8/3. So that's 2 and 2/3, right? So 2 and 2/3 would be about right here. So, all right, so that's going to cross here. All right, now the question is, I think it's easier to write these as a y equals so that you know what to shape. Okay. So if I rewrite the top one as 2, 2y greater than or equal to negative x plus 8 divided by 2, y is greater than or equal to negative 1/2 x plus 4. So we want the y to be greater than, so we're going to shade this side, right? Okay. Then the blue equation, 2y less than or equal to 4 plus x divided by 2, y less than or equal to 1/2 x plus 2. So we want it to be less than, so that's going to be this area here. And then finally, the purple, negative 2y less than or equal to negative 3x plus 8 divided by minus 2, minus 2, minus 2. That's going to flip the sign, right?
Yeah.
So y is going to be greater than or equal to 3/2 x minus 4. So that's the purple one. It's going to be greater than, it's going to be this side here. Okay? So what's the intersection? Y is greater than, right?
Y. Well, it started as less than.
Started as less than, but when I solved it as a y, I had to flip the sign and divide by negative 2, right? Okay? So therefore, this is the area that I want. This piece right here. Okay? So we need to find those 3 points. How do we find those?
Find the line 3.
Yes. So in this case, well, you tell me which one you want to do first.
Just the top and bottom here to the next. Just add those together.
So you're finding
Where the blue and black.
the blue, the black and the purple.
What?
You're doing the black and the purple to find this point. Is that what you said?
No, I was finding the other point at the top.
Which one were you finding?
The top two.
Oh, the black and the blue?
Yeah.
So we're finding this point here, okay? So this point here is black and the blue. If we add these together,
4y.
4y, we're adding them together,
Yeah.
equals
12.
12. So y equals 3. Okay, that's about 3, okay? And then what?
You can plug that into either one of those, so you can play it x plus 2.
X plus 2 times 3
8.
equals 8. Subtract 6. Subtract 6. X equals 2. So this point is 2. 2, 3. Okay? Then what?
Then, you just add the top one and the bottom one. Find another.
So we're doing the black and the purple?
Yeah.
So the black and the purple is going to be this point here. So the black and the purple. So if we add them together, the y's fall out. We're going to be getting 4x, right? X plus 3x.
4x equals 16.
And 8 plus x equals 16. X equals 4. And then what?
Then you plug the 4 in, so we 4 plus 2y equals 8.
4 plus 2y equals 8. Subtract 4. 2y equals 4. Y equals 2. So y equals 2. X equals 4. That was pretty close. Okay, so this is 4 too. And we need to find this spot. So that's what?
That'd be the bottom two.
The purple and the blue, right? The bottom two. Okay, so we're gonna, if we add those together, the y's eliminate, right?
Yeah.
So negative x plus 3x,
2x.
2x equals
12.
12. X equals 6. 1, 2, 3, 4, 5, 6. Oh, that was pretty good. Okay,
And then just plug it in, so it'd be negative 6 plus 2y equals 4.
negative 6. Oh, yeah, okay. Negative 6 plus 2y equals 4. Add 6. 2y equals 10. Y equals 5. 1, 2, 3, 4, 5. Oh, that was pretty close. I'll make it closer. So that's 5. Okay? Who's gonna go buy some graph paper today? Might be easier to do it this week. Okay?
With these questions on the next test, are we gonna have like little graph paper sections?
That's a good question. I haven't gotten that far. Hopefully. We'll see. We'll see what I can come up with. All right. Should we do a story problem? Oh, that was good. I was like, cue the drums. But I gotta, yeah, let's do it. Bring it on. Okay. All right, here we go. Factory produces pesticide A and B. For every barrel of A, factory emits 0.25 kilogram of carbon monoxide, CO, and 0.60 kilograms of sulfur dioxide, SO2. Okay, for every barrel of B, it emits 0.5 kilogram carbon dioxide and 0.2 kilograms of SO2. Laws restrict CO to 75 kilograms per day and SO2 has a max of 90 kilograms per day. So A, find system of inequalities for barrels per day and a graph. B, is it legal to produce 100 of A and 80 of B? And part C, is it legal to produce 60 of A and 160 of B? Okay. Victor, it must be your turn.
Would you set each of the barrels equal to their, like, the emission rate for the
Okay, so do you want to call, we're going to graph this. We could do A and B or X and Y, right? What do you want to do?
X and Y?
X and Y. So X is A and Y is B, right? Okay? Or you could label this A and B, I guess, either way. Either way you want to do it.
So when you do X equals 0.25.
Let's go with the law stuff first. So the laws restrict the carbon dioxide. Oh, actually, no, I guess we have to be careful because we can't go A and B, can we? Because X and Y has to be your carbon dioxide and your sulfur dioxide. That's not the same. So you want this to be carbon dioxide and this is sulfur dioxide? Or carbon monoxide and sulfur dioxide? Okay, so let's redo this because they're going to be a mix. So this is Y and this is X. Okay?
Okay, so X plus Y equals 75, or less than or equal to 75.
Let's see, the laws restrict carbon dioxide to 75. So if this is your carbon dioxide, 75 is the limit, right? And
90 is the limit.
90 is the limit for the SO2. So that's 90. Right, for the SO2. So we're literally in the box, right? Or a rectangle, I guess. Okay? So now let's talk about pesticide A. Here, let's do that. So pesticide A is what?
It emits 0.25 CO2 and 0.6
So 0.25 of the carbon dioxide. I'm going to put C for carbon dioxide. Okay?
plus 0.6S.
plus 0.6 times the sulfur dioxide.
And then B is 0.5C plus 0.2S.
2S. Okay? And that has to be within those boxes, right?
Yeah.
Okay? So, if the carbon dioxide is 0, this is 0.6, right? 0.6. And if the sulfur dioxide is 0,
It's 0.25.
this is 0.25. And I should have done this in a different color, that's all right. So this one's going to be 0.5C, which is going to be slightly less, right? And this is going to be 0.25S, which is also going to be slightly less. Those are not parallel, but pretend they are. So the question is, how much can we produce of each, right? Okay. So we can produce as much to fill all this. These probably cross at some point. The question is, which one's which?
Well, does it matter? It's not going to go into the negative.
Yeah, the question is, oh wait, did I draw that wrong?
I think so.
I did draw that wrong, didn't I? Because, yeah, this is going to look like this. It's going to look something like this. It's going to cross somewhere here, right? But the idea here is we can produce all this up to here. So the question is, how much can we produce of each? Right? So, okay, so we could add, let me think here.
Are A and B variables within themselves?
Yeah. So pesticide A consists of carbon monoxide and that, right? So the question is, we really need to see how much carbon dioxide and how much sulfur dioxide, right? So if I'm producing 0.25 of X plus 0.5 of Y, this has to be less than or equal to the limit of carbon dioxide, which is what? 75. And now let's look at this piece here. 0.6 of X plus 0.25 of Y has to be less than or equal to sulfur dioxide limit, right? Which is 90. Correct? Okay.
Wait, isn't it only 0.2 instead of 0.25 for the second Y?
Oh, you're right. I put a 5 there for some reason.
Wait, on the B.
Oh, wait. Maybe I should read. Let's make sure we're right here. Oh, no, this is 0.25 of carbon dioxide. No, that was right. 0.25, and this one's point. Yeah, that's correct.
But you wrote it down on the bottom as 0.25, didn't you?
That's an S. That's why I hate S's. Okay? So 0.25 of the carbon for A plus 0.5, so that's right. And this is, oh, I see what you're saying right there. That's why I hate S's. Because I always mix them up like that. All right, so now what?
And we substitute and eliminate.
We can substitute and eliminate or eliminate. Which one?
We can't really substitute it. Easy.
Yeah, substitution doesn't seem very fun on this one.
Either does eliminate.
I would say if we multiply this by 2, or by 20, and this by 50, we can eliminate the lives, right? And get rid of the decimal. So 20 times 1/4 is 5x. 20 times a half is 10y. And 20 times 75 is 1,500. 50 times.
You should do -50.
Yeah, that's a good idea. So 50 times 0.6 is 3x, right? Check my math on that. And it's negative. 50 times 0.2, 1/10 of 50 is 5, right? -5y equals 50 times 9 is 4,500, and it's negative. Did I do that right?
No, I think it's -10.
Check my math. 1/10. No, let's see, 2/10 of 50
It is 10.
is 10. Yeah, we wanted that because we wanted that to subtract. You're right. Okay, is everything else good?
Yes.
Are you using your bad calculator on there?
Yeah.
Shame on you.
My
Okay.
other one's in my backpack.
What'd you say?
The other one's in my backpack. And I'm trying to be quick.
All right, so I've got 2x equals, that's -3,000. Is that right?
Yes.
So x equals -1,500. Is that right?
These equations are set up right.
I think they are set up right. I just probably did a mistake here. 1/4 of 20 is 5.
Yeah.
10.
-3x, not -3x. -30.
Oh, this should be -30? Okay, that makes better sense. Okay, so if that's -25x equals -3,000, there we go, divide by -25. Now I got x as a positive number. X is what? 25, 1, 25, 52, 120? Okay, that's better. Okay, so x is 120. And if I plug that into, I think that one's easier. 5 times 120 plus 10y equals 1,500. 5 times 12 is 600 minus 600 minus 600. 10y equals 900 divided by 10, y equals 90. Okay?
That won't work though, because x is
120 goes out of bounds.
Oh, that does go out of bounds, doesn't it?
1,300, no, 1,500.
That's just legal.
17 times.
Can't do it.
75
Can't cross the border.
Ended up as illegal.
Yeah, we've got a problem here. Let's see here. What am I doing wrong?
No,
You copied it.
75 times 40 is.
Oh, okay.
Oh,
Or is it cheap? It does look like it's. That's why I checked those windows.
I don't think you added them, because how did you just make it negative?
All right, maybe we should have done this part. Let's do this again. Because I think that's where we made a mistake. So the hint is here, multiply the first one by 4 and the second one by 5. 4 times 1/4 is 1x. 4 times a half is plus 2y. 4 times 75 is 300. If we do this, 5 times 0.6 is 3x, right? Yeah. 5 times 0.2 is y. And then, actually, I should keep my things here. This is less than or equal to 300. And this one is less than or equal to 450. That's better. So let's redraw our graph now. So this is the wrong graph. Okay, so the idea here is we're going to emit stuff here. Okay, so if x is 0, if y is 0, x is 150. If x is, let's see, if x is 0, no, this is 300. This is 150. Okay? Now we do this one. If x is 0, y is 450. So we got this. 450. If y is 0, x is 150. 150. Okay, so this is what it looks like. This is the area that we need to worry about, right? That's much better. This graph was completely wrong because we're talking about totals. So we could emit up to 150, let's see, what does my X represent? X is your carbon, this is your carbon monoxide, this is your SO2. I've completely flipped that around, haven't I?
Don't we still need the 90 and 75 lines?
The 90 and the 75. Oh, yes, we do, you're right. And so let's see, if this is SO2, so the 90 is going to be here. And your 75 line is going to be about half. There we go. So this is the area that we can operate in. Does that make sense? Okay.
No, because then why did we solve for that one that's completely out of there?
Because we made a mistake. This is what we're going with here. So we've also got y is greater than or equal to 0, x greater than or equal to 0, correct? So we've now graphed it properly. Okay? So we can operate basically in this rectangle here. 90 at most on the sulfur dioxide, 75 at most with the carbon dioxide. They cross outside of that. So the question is, so here's your system of equations right here. Now, is it legal to produce 100 of A?
Yeah, it should be y is
And
greater
80
than or
of B.
equal to 75, and then x is greater than 80.
So 100 of the A, so 100 of A, this is what we produce here, right? 100 of A is going to produce 0.25 of carbon monoxide plus 0.65 of
That's 6.
SO2.
That's 6 SO2.
So if we multiply this by 100, that'll be 25 of carbon monoxide and 65 of the
It's 0.6 on
SO2.
the top, not 0.65, because it's 0.6 S.
S, oh, you're right. That stupid S is killing me every freaking time. So 0.6, so 60 of the SO2. So is it okay to produce 100 of A? So 25 of the carbon monoxide is okay, and 60 is okay. So is this okay?
Yeah.
Yes. Is it legal to produce 80 of B? Oh, I should say yes to this. Is it legal to produce 80 of B? So 80 of B would be 80 times a half, so that would be 40 of the carbon monoxide, and 80 times 0.2 is 40?
Yeah.
40 of the SO2, okay? So if we produce this together, so 25 plus 40 is 65 of the carbon monoxide, and 40 plus 60 equals 100 of SO2, that's no good. So that would be a no on that, because the combination would be that. You'd be okay on the carbon monoxide, right? Because 65 is less than here, but the 100 is outside, so the answer is no. Does that make sense?
If you write down no, is that full points?
Only if you can justify it. Okay? Now, 60 of A, so 60 of A, 60 times 0.25, so that's going to be 15 of your carbon monoxide. And 0.6 times 60 is 36, correct? 36 of your sulfur dioxide. 160 of B, so 160 of the B, so half of that's going to be 80. Already we have a no, correct? Because that's going to be 95 of your carbon monoxide. So that's going to be outside your limits. So that one's also a no. Does that make sense? No?
I mean, the last part makes sense.
Because we're outside of our limits. We can only go to 90. So we're already outside. So it doesn't matter what we do with the other 9. Does that make sense? Clear as mud? All right, I can't remember if I gave you any of these on there. That'll be good. Let's move on to 6.1. All right, now, .1. Oh, did I delete the cap off too long? Looks like I lost my black. Maybe it'll come back. 6.1, which is matrices. Now, here's the funny thing about matrices. Two funny things. Number one, some of you are going to hate them and some of you are going to love them. And it's really hard to predict. Number two, you can take an entire class called linear algebra, and all it is matrices. And so it's going to be fun. So anyway, I think at the beginning here, matrices are another way to do systems of equations. Okay? So let's say, for example, I have the system of equations 3x minus 2y plus z equals 5, x minus plus 3y minus z equals 0, and negative x plus 4z equals 11. Okay? So this is my system of 3 equations, 3 unknowns. You all know how to solve that, correct? Okay? Now, one of the things I could do is I could write this as the augmented matrix. Augmented matrix. And the idea here is I'm going to ignore all the letters and I'm just going to write the coefficients. So this is going to be 3, negative 2, 1, and 5. This is going to be 1, 3, negative 1, 0, negative 1, I'm going to have to put a 0 here, 4, and 11. And then I'm going to just make that a matrix. Okay? If that were a test question, how many of you would like to do it? It's not too bad, right? Okay? So that is just what we call the augmented matrix. Now, Okay. I don't know if I'll give you that one, but I might. I might if I'm feeling charitable. Okay, so, what'd you say?
I was gonna ask what we're doing with the augmented
That's
matrix.
where we're going next. Okay, yes.
Wouldn't that turn, when you put it to the matrix, wouldn't it be a 3 by 3 equals a 1 by 3 instead of writing it like
You're
that?
jumping ahead of me.
Okay.
But yes, you're correct. Okay, well, I don't think we're gonna do that today, but we will eventually. Okay? Let me do another one. So let's say, in fact, here's what I'm going to do. You guys understand that? Can I erase that? Because the one terrible thing about matrices is they take up a lot of paper, so I will just warn you. They are going to take up a lot of paper. Okay? What if I said that I wanted you to solve x minus y plus 3z equals 4, x plus 2y minus 2z equals 10, and 3x minus y plus 5z equals 14. Okay, so here's what we're going to do. We're going to solve this two methods simultaneously. First question is, who haven't I picked on? Kelly, can you write the augmented matrix for me?
Okay. So 1, -1, 3, and 4. And then 1, 2, -2, and 10. And then 3, -1 is 5. And then 14.
Okay. All right, so we're going to solve this simultaneously with both matrices and with augmented matrix. Now, let me just mention here, your goal when we're doing it with matrices, our goal is to get a 1, 0, 0, 1, 0, 1. These can be whatever they're going to be. And then the idea here is, in fact, I'm going to do this. This is what we sometimes refer to as the solution set. Okay? So the idea here is if I had, for example, let's pretend that the bottom row, this represents what? This is the z column, right? So this would represent z equals 3, correct? Then, if I had, let's say, -2 here, I could plug in -2 and then back solve, right? I could use substitution to get the y value and then substitution to get the x value, right? Does that make sense? So here's your goal, is you want to turn this into that, okay? Now, I'm going to erase that. Now, one of the nice things is, okay, I've already got a 1 in this place, correct? Okay, now if I were to use elimination and I wanted to eliminate the x's, the easiest thing would be to take these first two columns and I could just subtract them, correct? Okay, so x minus x is 0. -y minus 2y is -3y, correct? 3z minus a -2z is 5z minus negative.
Oh, yeah, okay.
Okay. 4 minus 10 is -14. Now I could write a 0x there if I wanted to, correct? 4 minus 10 is -6. Very good, thank you. Okay, now the idea here is I can do the same thing, okay? I'm going to rewrite the top equation 1, -1, 3, and 4. Just rewriting it, okay? Now the idea here is if I'm using this, I'm going to subtract the second row and I'm going to write the answer on the second row, Okay? 1 minus 1 is 0. -1 minus 2 is -3. 3 minus -2 is 5. 4 minus 10 is -6. So I've got the same thing here as I do here. Do you see that? Okay. So now the idea here is I want to eliminate x again. What would be the easiest way to do that?
Can we use the equation we already built?
So we can take these two equations, right? And if I multiply this by a -3, then I can add them. So -3x plus x is 0x, right? -3 times -y, 3y minus y is 2y. -3 times +3, -9z plus 5z is 14z.
-4z.
So -12 plus 14. Oh, you're right. -4z. Wait. -3 is, so -9 plus 5 is -4. You're right. Okay? Then -12 plus 14 is 2. Correct?
Yes.
I can do the same thing here. I'm going to multiply the first equation by -3 and add it. So -3 plus 3 is 0. +3 minus 1 is 2. -9 plus 5 is -4. -12 plus 14 is 2. So now, do you see these are exactly the same? Okay? So we've just done the same thing. Now, remember, my goal is to get a 1 on the diagonals. And I could divide this by -3, or I can divide this by 2 and then flip rows, correct?
Why did you flip?
Because I can change rows
Okay.
if I want to. Okay? So here's what I'm going to do. I'm going to divide this by 2, and I'm going to move the row up. So the top row is going to be the same, 1, -1, 3, 4. I'm going to divide this by 2, and I'm going to put a 0. 2 divided by 2 is 1. -4 divided by 2 is -2. 2 divided by 2 is 1. And then I'm going to rewrite this equation here, 0, -3, 5, -6. Okay? So all I've done is I've swapped these two rows, and I've divided the bottom row by 2. Does that make sense? Okay? And I could do the same thing here. I could flip these rows, right, and divide by 2. In fact, I will rewrite it as y minus 2z equals 1, and -3y plus 5z equals -6. Okay? So essentially, I've done the same thing on both sides, correct? Okay, now I want to turn this into a 0. Okay, I want to eliminate the y's. What's the easiest way to eliminate the y's? Multiply this by 3, right? So 3y minus 3y is big 0y, correct? 3 times -2 is -6 plus 5, -z. 3 minus 6 is -3. Okay? I'm going to do the same thing here. I'm going to multiply this by 3. 3 times 0, 0 plus 0 is 0. So I'm going to rewrite the top one. 1, -1, 3, and 4. I haven't done anything with that. I like this one here, 0, 1, -2, 1. Haven't changed anything. Now I'm going to take 3 times 0, 0 plus 0 is 0. 3 times 1 is 3, minus 3 is 0. 3 times -2 is -6 plus 5 is 1. And 3 times 1 is 3 minus 6, -3. Okay? Now, let's see here. This is a positive z. So I've got z equals -3, and this represents z equals -3. You agree with that? If I were doing it here, what would I do next? I'd plug it probably back into this equation here, right? Y minus 2 times -3 equals 1. -2 times -3? Not 5. Positive 6, right?
Oh, wait, yeah.
So subtract 6, y equals -5. Is that what you meant?
Yeah.
You were just jumping ahead. Okay? I can do the same thing because this represents z equals -3. And when I plug it back into this equation here, I'm going to get y equals -5. Correct? If I've got z equals -3, y equals -5, what do? I could plug it back into the top equation, right? So x minus y, which is -5, plus 3 times z, which is -3, equals 4. Okay? 3 times -3 is -9 plus 5 is -4. X minus 4 equals 4. Add 4. X equals 8. Does that make sense?
On your bottom one, you have 1, -3, should it be -1, -3? Because we got,
Oh, wait, did I make a mistake?
yeah,
Oh, I did. This was -6 plus 5. That was -z.
Yeah.
So +3.
Okay.
So that was a -1. So z equals +3.
does that change everything?
Yeah,
It changes everything because now I messed up my sign. So it is really easy to mess up your signs this way.
So all the diagonals have to be +1.
So you want these to be
negative.
positive? Well, if you get -z equals -3, you can make them both positive very easily, right? I'm multiplying by -1.
Okay, but you can't have a -1.
Well, you can make that positive just by multiplying by -1.
Yeah,
right?
that's not what I'm asking. If it was -1 equals
-z
positive,
equals -3. Solve that.
yeah, that's +3. I'm asking for the matrix rule. You said it has to be one's diagonal. Can it be a -1 ever?
Yeah, but then you can change it to a positive one really easily.
So,
Why do you
no,
want it
it
to be
can't be, it
negative?
has to be a positive one. So if it is a -1, you have to change it, is what he's saying.
Gotcha, thank you.
Question.
Do we have to do matrices, or can we just do that way?
We're learning matrices this chapter. This whole chapter is going to be matrices. We're going to go crazy on matrices. So yes, you have to learn both ways. Okay? Should we learn another one? This time,
Like, what's the advantage of using it?
the advantage of using it is it's really easy to teach computers. And also, if you go to the master's degree in statistics, you need to know linear algebra.
Isn't y equal to 7 then?
So yeah, we didn't finish this. Okay, so if z equals 3, so this one is y minus 2 times 3 equals 1. So that's -6 plus 6. So y does equal 7. And then we need to plug it into here. X minus 7 plus 3 times 3 equals 4. 9 minus 7 is 2. Subtract 2. X equals 2. Okay? Does that make sense? All right.
Were you showing us that whole left side just to reference, or is that how you do matrices?
I was showing you just a reference that will give you the same answer.
Okay,
So we're gonna go a whole hog on matrices now. Okay?
So
Now-
everything below the line of +1s has to be zeros, right?
Yes. The idea is you're gonna kind of work in columns because you want to eliminate certain variables. And so, what I just showed, let's see. Trying to remember what we call this. Okay, so this right here is called row echelon form. Row echelon form. Okay, they also have something called Gauss-Jordan form. The nice thing about Gauss-Jordan form, it's more work, 1, 0, 0, 0, 1, 0, 0, 0, 1. But if you have 1, 2, 3, the nice thing about this is you can tell me what the answers are, right? X equals 1, Y equals 2, Z equals 3, right? And so you can go from row echelon form, where these numbers are whatever they are, to Gauss-Jordan by working the way up. So the idea, as we're doing a 3x3, try to get a 1 here first, and then work down. Get zeros here and zeros here. Then you're going to want a 1 here, and you're going to work both directions. And then you're going to get a 1 here, and then you're going to work up. So that's kind of the pattern that you're going to try to follow. Okay? The computers are really good at this, a lot better than you are, but you need to learn how to do it yourself so you can tell the computer how to do it. Caitlin's excited about this, I can tell. Okay. Okay, let's do another one here. This time we're not going to focus on this, we're just going to go straight for matrices, okay? All right. So here we go. So I've got 3 equations, 3 unknowns. 4x plus 8y minus 4z equals 4. 3x plus 8y plus 5z equals negative 11. Negative 2x plus y plus 12z equals negative 17. Okay? So, Dino, can you help me find the augmented matrix?
Yep.
Okay?
This would be 4, 8, negative 4, 2, 3, 8, 5, negative 11, negative 2, 1, 12, negative 7.
Okay, so we've got our matrix. Okay? We're solving this with matrices. Yes?
Can you rearrange this to get it closer to our goal? Like, we already have a 1 in the Y column, can we just move it up to the second row? Or is that
You can rearrange rows any way that you want. And yes, you could, but the problem is, what's your first goal? You want to get a 1 here. Now, if I had a 1 here, I would just change these so that the 1 was here. Okay? Now, the question is, what's the easiest way to get a 1 here? Okay? You see these are all easily divisible by 4?
Yeah.
If I divide by 3, I'm going to get a bunch of fractions here. That's not going to be nice. If I divide by 2, I'm going to get a bunch of fractions here. That's not going to be nice either. Okay? So the first thing I want to do is I want to get a 1 here. The easiest way is to simply divide that by 4. Do you see that? Okay? So can you do that, do you know?
Yes, you 1, 2, negative 1,
And 1. Okay, so I've made my first goal here. Okay? Now, you're going to want to work in columns. Now that I've got a 1 here, okay, I want to get a 0 and a 0 here.
So we're not doing the Gus Jordan form or whatever. We're doing that.
You know, it might be fun to do that one time, okay? So that's a good idea. We'll do it on here. Problem is, I'm gonna have to bust my butt a little bit to get there, okay? So are you cool with me going fast, or do you want me to go slow? Okay. Now, I need to turn this 3 into a 0. I've got a 1 here. What's the easiest way to turn that 3 into a 0? I can times by -3, right? You see that? So -3 plus 3 is 0, correct? -3 times 2 is? -6 plus 8 is 2. -3 times -1, 3 plus 5, 8. Excuse me. Yeah, 3 plus 5 is 8. -3 minus 11, -14. Okay, so I've got a 0 here. Now I need to turn that -2 into a 0. How do I do that?
Times the top row by 2.
We're going to times the top row by 2 and add, right? So 2 minus 2 is 0. 2 times 2 is 4 plus 1, 5. 2 times -1, -2 plus 12 is 10. And 2 times 1 is 2. Minus 17 is -15. Are you with me so far?
So that first line we did is locked in.
Focus. There we go. The first line is now locked in because we've got, oh, sorry.
Just turn the screen, it might focus automatically, just pointing straight at it. Other way.
Okay. Okay, so now, what's my next goal? Here, I'll stand here. It likes to focus on me. Okay? What's my next goal? I want to get a 1 here. I can either divide by 2, or I could divide by 5 and move it up there. Which would you rather do? It doesn't matter. We're just going to divide this by 2, okay? So we're going to divide by 2. Top row is going to stay the same. 1, 2, -1, 1. We're going to divide the middle row by 2. 0, 1, 4, -7. Okay? Now, I want to get a 0 here. How do I get a 0 here? I can multiply by -5, right? And add. Okay? So in this case, -5 times 0 is 0, plus 0 is 0. Correct? -5 plus 5 is 0. -20 plus 10. -20 plus 10 is -10, right? 35 minus 15 is 20. Okay? Now at this point I can get z equals, right? Because this is easy. But just to in fact, let's go at, but because we wanted to try the Gauss-Jordan method, it's good practice for you guys. You guys will hate it. And honestly, you don't need it, but it is nice because then you can get x equals y equals z equals, right? Okay? So I'm going to divide this by -10, correct? So my bottom row is going to be 0, 0, 1, -2. Correct?
Wait, what did you do?
I divided by -10. So I've got my bottom row, right? Now the question is, if I keep my middle row the same, 0, 1, 4, -7, how do I turn this 2 into a 0? I can times this by -2 and add, right? -2 times 0 is 0, plus 1 is 1. -2 plus 2 is 0. -8 minus 1, -9. Positive 14 plus 1 is 15. Are you with me still? Yes.
Why are you trying to eliminate that too?
Why am I? Because I want to get zeros here and here. I've got a 0 here, I want to turn that into a 0.
Negative 2 on the bottom, he's eliminating on the top.
I'm eliminating the top now. Okay? Now, my bottom row is perfectly fine, right? 0, 0, 1, -2. I need to get a 0 and a 0 here. How do I do that?
You take the bottom row and times it both by -4 first.
-4 first, right? So 0, 0 plus 0 is 0. 0 plus 1 is 1. -4 plus 4 is 0. Positive 8 minus 7 is positive 1. Okay? So now we're pretty good, right? Now, how do I get the 0 here when I've got a -9?
Times the bottom row by 9.
I'm going to multiply the bottom row by 9. So 0 and 1 is 1. 0 and 0 is 0. 9 minus 9 is 0. 9 times -2 is -18 plus 15.
3.
-3.
3. -3. Okay, so what does this represent now? X equals -3. Y equals 1. Z equals -2.
There you go.
So that is Gauss-Jordan elimination. Now, two things that I just want to point out really quick. You should hear this before you go. What happens if on the bottom row I get 0, 0, 0, 3?
It's negative.
What does
No
this tell me?
solution.
The remainder of 3, right?
0 equals 3, right?
Yeah. Oh,
So this is no solution. What if I get 0, 0, 0, 0?
It's 0. Or it's
It's
all
0 equals 0,
solutions.
so it's like all.
Dependent.
Yeah.
Yeah, there you go.
We didn't have time to go over those, but you will see that on your homework. Okay? This was fun. Gonna be a fun quiz tomorrow. After all that easy graph and stuff, you'll be like, oh.
It's gonna be a long quiz.
All right, I'll only give you 7 of these on the quiz tomorrow. See y'all tomorrow.
Yeah, but teacher credit that.
Here, let me turn this off, unless you want to record it.
It says that you put my